Problem 4. A, B, and C are distributing candies among themselves. The original plan to split the candies was a ratio of 3 to 4 to 5. But when distributing, there was a mistake and the ratio was 5 to 6 to 7. One person received 15 less candies than the original plan. Who is this person and how many candies are there in all? Alright, so first you might be wondering, well, if somebody received 15 less candies, how come the ratio is bigger? Every single number here is bigger. Well, that's because these are two different ratios, right? And the two ratios are using different sized units. So this unit and this unit are different sized units. And also when it says one person received 15 less candies, you also have to realize that if one person received 15 less candies, then somebody else must have received 15 more candies. So that's the type of thinking you should be that should be popping up in your head when you read this problem. Let's first write down what we know. This is going to be our before ratio, before the mistake, and this is our after. The before ratio is really just the plan, and the after is what really happened. So let's make this A to B to C. So the before ratio was 3 to 4 to 5. We already know that given in the problem. The second ratio is also given in the problem. 5 to 6 to 7. And when solving problems like this, when the ratio changes, we need to think about one thing. What value doesn't change? The value that doesn't change is actually, so two people's candies changed, right? One person received 15 less candies while another person received 15 more. So the person that didn't have any change at all did not change, but that can't be our unchanging value because we don't know who that person is yet. But what we do know is the total amount of candies. The total amount of candies, I'm going to add another column here, and it's going to be a total, will always stay the same. So what's the total here? We just add up 3 and 4 and 5. 3 plus 4 is 7. 7 plus 5 is 12. So 12 units. In our second one, we do 5 plus 6, which is 11. 11 plus 7, which is 18. So 18 units. Now you must be wondering, wait, so you said that the total never changes, but how come the units are different? Again, at the very beginning of this problem, I try to clarify that these two units don't have the same size. These are different sized units, which means that we need to convert to them. So just making them into a more breathable kind of unit. So we have to make it so both of these ratios can use it. So how am I going to do that? Well, we're going to find the LCM, or least common multiple, of 12 and 18, and this is something we've already covered. 12 and 18, so let's take 18 and let's skip count by it, and let's see which of the multiples is the least common multiple. So 18, 36. On the second multiple, 36. 36 is 3 times 12. So LCM of 12 and 18 is 36. So what we can do now is assume that there is 36 candies. Remember how in our last video about the classrooms, everything was much more easier because we assumed that in every single classroom there was only one student? Well, in this, we're just trying to test whatever is convenient for us as long as the ratio stays the same. And right now we're just going to assume that the total number of candies is 36, and that never changes. So the total is 36 candies. All right, so this is our new ratio. A to B to C, but this time instead of units, this is going to be the actual number of candies. All right, so this is 3 out of 12 units. This is actually 3/12. So let me write it this way: 3/12, 4/12, 5/12. So what's 3/12 of 36? 3/12 of 36 is really 1/4 of 36, which is 9. So A has 9 candies at first. Actually, it might be better if I do 9 candies. I'll write the word so nobody gets confused. Now what's 4/12 or 1/3 of 36? 1/3 of 36 is 12 candies, so 12 candies. And C, 5/12 of candies. What is 5/12 of 36? Well, 1/12 would be 3, so 3 times 5 is 15, so 15 candies. This is the before ratio. Now what's our after ratio? This is, since this, remember, this unit is now 18, so the denominator is 18. What's 5/18 of 36? That's 10 candies. What's 1/3 or 6/18 of 36? That's 12 candies. And what's 7/18 of 36? That would be 14 candies. Now that we have the exact number of candies, let's observe. So A at first, it was supposed to be given 9 candies, but then it got 10 candies. C was supposed to have 15 candies, but now it has 14 candies. And B never changed. It was always 12 to 12. So in this ratio right here, we have the same size unit. We have the same size unit by assuming that was 36 candies in total. And we learned that B was the person that never changed, and C was the person who got less. So one of these units, so one unit right here, and this unit is talking about candies, by the way, and this isn't the actual number of candies, this is just a unit we thought of. One unit is equal to 15 candies. Okay, I'm crossing all these candies out because now we have a new candy. It's going to get confusing. So this is our new ratio, 9 to 12 to 15, and this is our another new ratio, 10 to 12 to 14. So one unit equals 15 candies. And what's the question asking for? We're trying to find who received less, so that would be C, and how many candies are there in all. And we're going, since there's a total of 36 candies, we do 36 times 15, which is 360 plus 180, which equals 540. So C, and there are 540 candies in all. This is the final answer.